you're flying the space shuttle and you notice that the propellant is gone on one side of the reaction control system. And now you've got to move the propellant. What are you going to do? How are you going to do that? Well, besides solving that problem, we, at the end of this video, are going to show you how to win a coffee book of the Apollo spacecraft. That's right, it's a coffee book with the diagrams, which are used as art with a description that we turned into a coffee book for you, and that is to win. We're going to show you that at the end. But before we do that, we got to figure out how to move the propellant from one side of the reaction control system to the other. And how we're going to do that is with these switches here, the Aft RCS Crossfeed Switch. It takes you to the Aft RCS Crossfeed Switch, and that's what these are right here. And what they do is they control a pair of valves, one fuel and one oxidizer, which allow the propellant to flow to the jets of the corresponding manifold. So the positions of the four switches are open, GPC, or general purpose computer, and close. The GPC position allows the orbiter computer to automatically control the crossfeed valves, and the open and close position enable manual control. So GPC, the computer, is doing all the crossfeed for you, work for you, and open and close is when you're doing it, you're bypassing the computer. The open position of the aft left RCS crossfeed 1, 2, and 3, 4, 5 switches right here permits the aft left RCS to supply propellants to the aft right RCS crossfeed valve, which must be opened by placing the aft RCS crossfeeds 1, 2, 3, 4, 5 switch to the open position for the propellant to flow to the aft right RCS jets. Note that the aft right receiving RCS tank isolation 1, 2, 3, 4, 5 and B valves must be closed. So the what you're doing is you're moving the propellant here to the left side. So permits the left RCS to, move it from the left side. So the aft left RCS to supply propellants to the RCS crossfeeds must be in the open, and the switches must be opened here. Note that the aft right receiving RCS isolation tank valves must be closed. We're going to go over that more in detail with for our paying subscribers. Now, the closed position of the aft left and aft right RCS crossfeeds 1, 2, and 3 switches, that isolates the crossfeed capability. So what it's doing is it's not allowing for the crossfeed to actually move the propellants. The crossfeed of the aft right RCS of the left RCS would be accomplished by positioning the aft right and the left RCS crossfeed switches to open position on the aft left RCS isolation 1, 2, 3, 4 switches to close. Okay, so what you're doing is you're moving from here, you open it up, and then you move it around, and then you open it up over here to go into the left RCS crossfeed. Okay, so this is a little complex, but it's basically opening these valves and then opening this RCS crossfeed. What that's going to do is going to allow to the flow of it. So we're going to go now into the schematic so you can see how this works. and that is for our Patreon subscribing. The paying ones, which is only for $5 a month, a cup of coffee a month, and you'll be able to go deep into detail on this. Or you can sign up for free, and free. It doesn't cost you anything, and you can go over the schematics with me. So if you are a Patreon subscriber and you either free or paying, and you click on schematic, how would you like to win a coffee table book on the Apollo lunar lander? That's right, for free. Win it if you just join my Patreon page for $5 a month, the minimum charge, and you could win this book, the world's only coffee table book about the Apollo lunar lander.